All right, welcome back. So let's try to work on the Chapter 7 study guide. This is going to be hopefully a quick one, not a particularly hard chapter. Let's go. So first thing that we want to note is we have the interior angle sum, meaning think about the inside of a shape, right? There's all these individual angles within a shape. What do they all add up to, right? That's the question. And so there's a formula for this. Let's look back at our key facts. You could look at this through some of the notes that I've posted on Google Classroom. Well, the formula that we have here is going to tell us the interior angle formula, where n is the number of sides. Okay? So, how many sides does this shape have? Well, just count it up. You're going to notice that there's 6 sides. 1, 2, 3, 4, 5, 6. And so the interior angle sum formula tells us, well, if the number of sides is 6, then we're going to have 6 minus 2 times 180. Well, 6 minus 2 is just 4 times 180. That is just 720. And turns out 720 degrees is going to be basically the sum of all the angles on the inside. If you add up all of these, it's going to be 720 total. Now, let's do the same one. This one doesn't have a shape given. Number 2 basically tells you 21. That's your n value. So n minus 2 times 180. Well, that's just going to give you 21 minus 2 times 180. That's going to just give you 19 times 180. And on a calculator, if you want to be exact, that's 3,420 degrees. If you have a 21-sided shape, if you add up all the angles on the inside, that's going to be 3,420 degrees. We move on to the next section. This is just going to tell us one exterior angle. We just want to find one of those angles, okay? So this is a different formula. This one is going to be the exterior angle of the outside angle. And remember, the outside angle is such that if you were to keep drawing out your shape, right? If you kept drawing out your shape, well, this right here, this right here, this right here, all of these are going to be the exterior angles. Like, what is the measurement of that one angle, okay? So the formula is as follows: 360 divided by the number of sides. I already counted it, but 1, 2, 3, 4, 5, 6, 7. That's 7 sides. So that's 360 divided by 7. Well, on a calculator, that's about 51.428, ... keeps going. We're just going to round it to 51.4 degrees. We don't need to bump the number up because it's 428. And we only did this because it's asking for the nearest tenth. Now, that's basically going to be the sum of, not the sum. That's going to be every single angle, if you think about it, including this one, this one, this one, this one, this one, and this one. Okay. Okay, well, this one tells you it's a 13-sided shape. Well, if you have a 13-sided shape, it's going to be 360 divided by 13. That's going to give you approximately, let's make it a squiggly, that's 27.692, ... That's about 27.7 degrees. And we do need to round that up because it's bigger than 9. Okay. So that's going to be the measure of one exterior angle. Now for the next one, remember, this is a 4-sided shape. That's a quadrilateral. That's going to be just all 4 of these angles added up. Okay, they all need to add up to 360 because, again, triangles add up to 180. Quadrilaterals are double that. So I'm just going to write everything out. It doesn't really matter the order that you go in as long as everything kind of adds up in like terms. So that's going to give us, let's see, I'm going to zoom in, 360. Okay, well, if you add this up on a calculator, you will be getting 280. 16x just drops down, 360. From here, just get x by itself. Shouldn't be a particularly hard process. This is going to cancel. You're going to get 16x equals 80. Divide. Then you're going to end up with x is equal to 5 as your answer. If you wanted to check your answer, You would plug it back in. Once you plug it back in, all of these should add up to 360. Here's the next one. Well, if you add up all of these, notice that these two are like terms, right? And these two are like terms. And so we know that this one is going to be just 36x. This one is going to be 180, right? And so that's just going to be equal to 360 because all of them need to add to 360. So let's do that. Again, if you add these up, I mean, let's just write it out. This is essentially what's going on. Equals to 360. Well, that's just going to give us 36x. This is going to give us 180 equals 360. If you subtract 180 on both sides, you should end up with 36x equals 180 divided by 36. And you should end up with x is equal to 5, coincidentally, just like the last one. And that should be your answer. It's going to bug me that I didn't write this out. There you go. Let's do number 7, moving along. Again, two types. Remember, there's two different types of ways in which you have to solve these. These, if you look at these are diagonal angles, right? We know they're diagonal because it looks this way. Another two diagonal will be K and M. Well, if they're diagonal angles, they're just equal to each other, okay? You have 12x minus 2 is equal to 10x plus 14. And then from here, it's just a matter of simplifying. So subtract 10x on both sides. These are going to cancel. You're going to get 2x minus 2 is equal to 14. Again, there's no 180 involved here because opposite angles for any type of parallelogram are going to be congruent. Divide this by 2. You should end up with x equals 8. Now, be very careful. You don't want to just leave this as your answer because you have to read the question. The question is asking, find measure of angle n. That's how you read this, measure of angle n. So that's this guy right here. You have to plug it back in. So if you are to plug it back in, again, you have to plug it into angle n. So let me just do the work on the side here. That's going to be 10x plus 14. Well, that's just 10, right? 10 times 8, which is just going to give us 80 plus 14. That's just 94 degrees. And that's going to be the measure of really both of these angles, but in this case, angle n, which is what we wanted. Okay. Let's find measure of angle t. You're going to notice right off the bat, something's weird. There's nothing here, and so we're going to have to figure this out. Well, remember, these are not diagonal angles, but they're adjacent to each other, so we need to add them to 180. Basically, the side angles of a parallelogram, they need to add to 180. And so if we write that out, again, these two are going to combine. These two are going to combine. Let me write that on the side here. That is going to give us, again, like terms, this is going to be 14x, right? So that's 14x, and this is going to be 12. And again, we're just going to equal it to 180. So oops, that's going to give us 180. Let's subtract. That's going to cancel. These are going to go away. We're going to get 14x is equal to 168 divided by 14. Taking it a step at a time. These cancel. You're going to get x is equal to 12. And here's the thing. We don't know what measure of angle t is. That's what we want to find. But we can't plug it into there. But we do know that we can plug it into here. And once we do that, we'll know exactly what this should be. Okay. So let's just plug it in. Plug into angle S. That'll be 6 times, again, we're plugging in 12. that's just going to give us 72 plus 3, which is 75. So in other words, if we rewrite this, RSUT, we know that 75 degrees is going to be angle S, right? Well, if that's 75, then this has to be 105. And if you're not sure why, well, remember, it needs to add up to 180. So the opposite, if you subtract it, you should get 105 degrees. Boom. Magic. So 105 degrees, I'm just going to write that in as the answer. Again, the way we got that was 180, I'll just keep it in bold, is equal to 105. 180 minus 75 is equal to 105. Okay? So if you got nothing out of that, again, this is your answer. Let's move on. Solve for x. These are really easy. I really hope no one misses these. These are parallelograms. Parallelograms have this neat feature where each parallel side is going to be congruent to each other. So you just set the equations equal. This is very simple. It's just asking you to solve for x, nothing too crazy. So that's 20 equals 5x. Divide by 5, divide by 5. Well, what do you know? This is going to give you 4 equals x. And yeah, that's it. Nothing too much to it. If you look at this side and this side, we know that these are also going to be parallel to each other, and so they are congruent. Subtract, subtract. This is going to give us 10 equals 2x. And then once you do that, divide by, ooh, that's going to bother me. Divide by 2. You're going to end up with 5 equals x. And there you go. I mean, if you wanted to, this is better practice, but we don't need to be specific. You could check your answer. Obviously, plug it in. Plug it in. You should get the same number. Okay, these two questions look similar, but they're a little bit different. Let's focus on each one individually. So number 11, we see that QC, this guy right here, is 2x minus 6, so let's write that in. Okay. And we see that CS, this guy right here, is x plus 2, according to what they've given us. And so let's write that in. And again, if you have two segments that are part of the diagonal in a parallelogram, you know that they are congruent. So all it takes is you need to write them as an equation, set them equal to each other. Just solve it like you normally would. This is going to cancel out. You're going to get x minus 6 equals 2. Add 6 to both sides. You're going to get x equals 8. Is this your answer? Not quite. We need to find QC. So plug it in to QC. That's this guy right here, right? So once we plug it in to QC, well, you know that QC is going to be 2 times 8 minus 6. That's 16 minus 6. Turns out your answer should be 10. You know you got the right answer if this is 10, and once you plug in x to the other one, this should also be 10. And trust me, if you plug in 8 plus 2, that's 10 as well. We look at this one. So again, we're going to do the same thing as before. EU is 4x plus 5, right? This guy is this guy. But this one's a little odd. If you look at this, okay, this whole thing is 11x plus 1. They're telling you that EG, from E to G, that's going to be 11x plus 1. And so it's not like the previous example where two halves are going to be set equal to each other because we don't know GU. We don't know the other half. Except we kind of do. Think about it this way. We know that if this diagonal is 4x plus 5, well, technically so is this one. Like if I really wanted to drive it home, this is also 4x plus 5, right? Think about that. And so there's two of them, and there's an easier way to kind of manifest that, if you wanted to double that, then that's going to be equal to 11x plus 1. Because again, this and this need to be actually the same length. We know they're equivalent. And so if we solve this out, that's going to be 8x plus 10 is equal to 11x plus 1. Let's simplify the best way that we can. This is going to give us 10 equals 3x plus 1. Subtract 1 on both sides. You're going to end up with 9 equals 3x. And finally, cancel out one last time to get 3 equals x. Okay. And so when you have 3 equals x, this guy, you can plug back in to find EG. What is EG? Well, turns out this is the equation for EG, right? So let's find EG. That's going to give us 11 times 3 plus 1, which is just 33 plus 1 is equal to 34. And turns out that's the length of this entire segment, which means each side is technically 17 and 17. If you were to plug it into here, you should see that it will be 17. 4 times 3 plus 5 is 17. Okay, we're going to pretty much speedrun this. I mean, this one is a square, right? You know it's a square because it has 4 congruent sides and even the angles are all 90. I mean, that needs to be the case. Okay, whenever you have 2 congruent pairs, that's basically just a kite. Please refer to the table on your notes. I'm not going to refer back to it. It even kind of looks like a kite, even though sometimes it won't look that much like a kite. Number 15, there really isn't any type of marking, nothing that tells you that any sides are congruent or parallel or any angles that are 90. The most that you can say, think about it, the most that you can say is that it's a 4-sided figure. That's all the information we have. And that, simply put, is just that it's a quadrilateral. 16 tells us that there's 2 parallel sides, but not the other ones. Those 2 are not parallel. They're not even congruent. So this is a classic example of a trapezoid. Okay, trapezoids have 2 different sides that are congruent. If you look at the next one, it almost looks like a square, except it's kind of like smushed, like if you smush a square. Now, all 4 sides are equal, which means this has to be a rhombus. Think of a rhombus as a square, except it just doesn't have 90-degree angles. Okay, and this one, again, these are parallel symbols, just like in number 16, except there's 2 pairs of them this time. So this is going to be a parallelogram. That is the best description for it. Okay, because all sides are parallel. Number 19, solve for x. Okay, remember, I'm going to refer to this. Okay, I already forgot to refer to this, but that one was easy enough. The mid segment is found by taking the average of the 2 endpoints, so A and C. So divide that by 2. And so, yeah, when you have these 2 segments, you add them up and you divide it in half, well, that's going to show you the middle point, the midpoint. Sorry, the mid segment. And so if we are to do that, okay, let's take 12 and 22, average it out. Well, that should give you the mid segment. So that's equal to 6x plus 5. Well, if we simplify this fraction, that's just going to give us 34 divided by 2 is equal to 6x plus 5. 34 divided by 2 is just 17. And then from here, just solve it like normal. You should end up with 12 is equal to 6x. And then once you divide by 6 on both sides, you should end up with 2 is equal to x. And in this case, the question only asked to solve for x. And so there you go. That's your answer. Nothing too crazy. Now, this example had 6x plus 5, the variable expression, in the center. What happens if it's somewhere else? Well, what happens if it's in the bottom this time? Well, it's going to be very similar. Just take your two end segments, add them up, 18 plus 3 plus 17x, and then take the average of them, which means cutting it in half, and then set it equal to the mid segment, which is 36. Okay. Well, we run into trouble here. There's a variable here, and you can't divide that by 2. So instead, what we can do is maybe take this guy and multiply him over, right? Cross multiply it so that this fraction cancels out. So that'll just become 36 times 2. So if we were to write that in, that's going to be 18 plus 3 plus 17x equals 36 times 2. Let's simplify on both sides. 18 plus 3 is just 21, plus 17x equals 72. That's 36 times 2. If you subtract on both sides, okay, you're going to end up with 17x is equal to 51. If you divide by 17 on both sides and possibly use a calculator, you should end up with x equals 3 as your answer. Okay. Okay, let's keep going. 4 different types of problems. Okay. If you look at number 21, remember, for regular trapezoids, the sides of a trapezoid always add up to 180. And so if we solve this expression as is, okay, let's combine like terms. That's just going to become 10x plus 90 equals 180. Subtract. 10x equals 90. Well, if you divide by 10 on both sides, turns out you just get x equals 9 as your answer. Wonderful. Okay. You can check your answer, plug it in. That'll give you 90 minus 10, which is 80. You know that 80 and 100, they both add up to 180. Okay. So the next one, again, sides of a trapezoid need to add up to 180. So 15x minus 20 plus 80 is equal to 180. Again, I would combine like terms on the left before you do any type of funny subtracting to the other side kind of thing. So that's just going to give you 15x plus 60 equals 180. Subtract 60 on both sides. This is going to cancel out. You're going to get 15x is equal to 120. Divide by 15, divide by 15. You should end up with x equals 8 as your answer, and we're done. Last two. Okay, so these are different. These are two examples of isosceles trapezoids where two sides are congruent, which means if two sides are congruent, if we look at the first one, then that means the two angles on the top and even the two on the bottom, although that one doesn't matter as much in this case, they are also congruent. Okay, these two should technically be equal to each other. Problem is, we don't know what's here, except we can figure that out real quick because we know that the other angle needs to be 180 minus 120, which gives us 60 degrees. This should be 60 degrees, okay? They need to add up to 180. So long story short, 60, right? This adds to 180. Now, we know that it's an isosceles trapezoid, so these should be mirror images. So set them equal. Solve it. And then once you solve it, you should end up with 4x equals 32. Divide by 4, divide by 4. What do you know? X is equal to 8. And beautiful answer. Last one, even easier. These two are congruent, which means angle E and angle D must also be congruent, right? It's kind of like a reflection. And so there's nothing to add here. I mean, you can just solve it as is, kind of like an equation. I mean, it is an equation. This is going to give you 84 equals 7x. Divide, divide. Oh boy, we're almost done. We are speed running this. X is 12. And we're done. I'm tired.